Hello everyone, this is Gunjan Goyal. I have cleared 13 papers of actuarial science and have approximately 2 years of corporate work experience where my specialization lies in general insurance. In this video, we'll be discussing the CM1 paper B, April 2023 indicative solutions. The solutions are as per the true and best of my knowledge and are indicative. So let's start with question 1. A company wishes to invest in a fleet of 50 vehicles for use by its workforce and will choose between two alternative vehicles for the entire fleet, an electric vehicle or a traditional internal combustion engine car. The electric vehicles incur a higher initial cost than the internal combustion engine cars, but have lower running and maintenance cost. Worksheet question 1 base gives details of the cost involved for each type of the vehicle. The company intends to run the fleet for a period of 5 years. It anticipates that the average annual mileage for each vehicle type will be 20,000 miles, spread uniformly over each year. So it said that these are spread uniformly over each year. So calculate for each vehicle type the present value of the total cost to the company of buying and running the fleet. You should use a risk discount rate of 4.5% per annum. So it said the risk discount rate of 4.5%. And let's see what is given in the base question 1 base sheet. So this is the vehicle ICE and vehicle type. So initial cost per vehicle of ICE is 30,000 payable at outset. And this is also payable at outset. And then the running cost, fixed cost, annual maintenance, and the tax. So let's make a sheet of all these where I have now noted down all these: annual maintenance cost, government tax, annual mileage, total number of vehicles, running cost is 3.5 and it increases by 4%. The maintenance increases by 25 and this discount rate is given to me as 4.5%. So starting with the very basic risk discount rate, I is given to us 4.5%. So the discount is calculated as I 1 by 1 plus I. Then since this vehicle average annual it will be spread uniformly over each year, then we have assumed that this is continuous. Okay, so running cost to be continuous. So I have calculated A bar 1 for continuous values, which is 1 minus C5, 1 minus V by ln 1 plus I, or 1 minus V by delta. Okay, this is A by 1. And I have been said that in question 1 base sheet that the government tax is payable at the start of each month, fixed cost. So for monthly cost, again to convert it to annually, I have calculated A due 112. Okay, so A due 112 is again 1 minus V by D12. So the formula for D12 given I is 12 into 1 minus 1 plus I to the power minus 1 by 12. That's the formula for D12 in the denominator. And I get this value. These are already given in the question. Starting with the question sheet, the original answer sheet contained of only 0, 1, 2, 3, 4, 5, these cells. I have inserted a cell of 0. Why? Because this money is payable at outset. The initial vehicle is payable at the outset. So payable at outset, I have 30,000 into the number of vehicles, which is 50. Okay. So there are 50 vehicles, for each we are calculating the cost. So this is then running costs. Running costs are payable at the start of the second year. First increase at the start of the second year, but they are generally paid at the start, if you can see. So means the cost will is payable in advance. So assuming in advance, and it is continuous over the time. So let's see. We have taken what? C12 is my running cost, which is 0.15, into my C11, which is the total number of vehicles, each number of vehicles you have taken, into that average annual mileage for each car, which is 20,000, into C6, which is my A bar 1, and into the increase That is, it is increasing 4% each year. So 1 plus 4% into the 1 plus 4% to the power time. So once you do this, you increase. In the next year, it will increase by 1, 4, and so on. And it will go till time 4. 5 payments, but 0 to 4. Okay. Next is the maintenance cost. If you see, the maintenance cost is paid at the end of the year. Okay, so maintenance cost is paid in arrears. So it will start from time 1. Maintenance cost is very easy. It is a fixed amount. So 50 into 500 for 50 vehicles. Okay. Plus there's an increase of 25. Okay. For each of the 50 vehicles. So 25 into 50 into the increases from the start of the second year, from the second year onwards. So in the first year, there will be no increase. So first year, it will be 18 minus 1, time minus 1, 0. And from second year onwards, it will keep on increasing. This will go from time 1 to time 5. Government tax is basically, again, government tax is given as 50 rupees into for 50 vehicles into, since it is paid monthly, so 50 is monthly, so I multiply it with 12 into a due 12 since to make it yearly payments. Okay, to make it yearly payments, we have done it. And it's a fixed cost. Each year, this much tax has to be paid. Again, paid in the beginning, since we have taken a due 12. Okay. Now, total cost, the thing is sum of all the things. Sum of all these columns is the total cost we are getting at the at each year. Then we calculate discounting factor. So for time 0, it is obviously v to the power 0, then v to the power 1, v to the power 5. Present value is nothing but total cost into the discounting factor, and then we calculate the sum of this. So this is for the IC, internal combustion engine. This was for IC, very straightforward. Similarly, we'll do for electric vehicles, 45,000 payable at outset, 0.04 fixed cost, and 150 payable midway through each year, increasing by 0.5, increasing by 5% each year. So again, 40,000 into 45,000 into 50 vehicles we have. Okay. Then we have the running cost. Running cost is again 0.04 is the mile driven into 20,000 into the 50 into a bar 1, which is fixed here. All year the running cost is fixed. Okay, and again all payable at the start of the year. Maintenance cost here is also it says maintenance cost is 150 payable midway through the year, increasing by 5% each year on the second payment. So midway, so I can bring it to the starting. So what I've done is, for the midway payments, 150 into 50 vehicles. So 150 into 50 vehicles into, since it is paid midway through the year, we need to bring it to the beginning of the year. So v to the power 0.5 and into the increase 1 plus I, which is 5% to the power time. It will not increase in the first year, but it will increase in second year onwards. There's no tax on electric vehicles. Therefore, total cost is sum of all these things, and discounting factor is just nothing but v to the power time, and present value is cost into discounting factor. Sum of this, we get the cost of the electric vehicles. Okay. So all of this, once you get this, they've said calculate for each vehicle type and recommend with reasons the most suitable type of vehicle for the fleet based on your answer in part 1, since it said 1 and 2 over here. So if you see the costing, the costing for electric vehicle comes down lesser than net present value. The present value of the electric vehicle is lesser. Hence, we will use electric vehicle to be chosen. A difference of 15,000 rupees is there between the two present values. Okay. The company wishes to consider how its estimate of annual mileage per car would impact the decision on which type of vehicle to choose for the fleet. Okay. Determine the annual average mileage per car, which will result in the same cost in present value terms for each fleet. So it's very easy. We'll just copy this sheet to question 1 part 3. Exactly copy this sheet, and it was an average annual mileage of 20,000. So you see difference is this. We'll calculate a row for difference, and we'll use goal seek, that is data tab, what if analysis, goal seek, and we'll try to make this difference 0. Okay, by changing cell as average annual mileage. So once you make this difference 0, you get an average annual mileage of 19,440.177. Okay. Then you have the company has now proposed to run a fleet for a shorter period of 3 years and to take account of the sale proceeds of the vehicles at the end of this period when making its decision. It expects the residual value of the vehicles at the end of 3 years to be 40% of the original purchase price for internal combustion engine cars and 50% for electrical vehicles. Copy your question 112 worksheet to question 4 worksheet and update your results and recommendation to take account of the company's new proposal. So again, copy this sheet, and it is said that now it will run only for 3 years. So we'll remove the fourth row and the fifth row from both the uh, calculations. Okay, once you remove the fourth and fifth row, you will get whatever your calculations do not change over here. The only thing which gets added is the sale proceeds. The sale proceeds get added because now the company is selling the vehicle. So it is 40% of the initial cost, or 40%, 0.4 into the initial cost. This is my sale proceeds, and now the total cash flow will be nothing but total cost minus the sale proceeds. Okay. This is there. And similarly for the electric vehicle also remains everything the same, only it becomes now 50% of the initial cost and cash flow changes to this. Once you are done with this, discounting factor remains the same and we get the present value. Okay, remember this gets discounted for a period of 3 years. This, since it's at the end of 3 years, if you see, and the end of 3 years, the company is selling the vehicle. So this gets discounted for 3 years. So here v to the power 3, and these are the two values. Amongst this also we see that the electric vehicle is still a better, still profitable than if you see for sales. Then if after sales, if we see, then we have internal combustion as a better present value than electric vehicle. Okay. The suitability of this model for helping the company to select the fleet. Again, this is a generic comment which all of you might write differently based on your answers. It is not possible for me to give one separate answer for this, but yes, you can write that EVs are the future of the EVs are coming as a future motor vehicles which will be widely used, since it saves a lot of on fuel as well, and it saves a lot on pollution as well. Does not impact pollution. The running costs are easier, and the policy, since the government is not taxing as per year, individuals might be more interested to buy this. Okay, and for the suitability of this model might not be a very good model since it's only examining for the 5 year terms. If examined on a longer year terms, it will give us better results. But currently, if we see that the present value of electric vehicles are much lesser than the present value of internal combustion engine. Okay, moving to question 2. This was the maximum question marks if it held this question in the entire paper, and but it was a very straightforward question. Nothing as per that was very difficult in this question. Only thing was one people had to crack that uniformly is mean continuously, and the challenge was that the monthly thing need to be done on multiplied by 12. Okay, coming to question 2. A life insurance company issues a 15-year unitized with profits contract to a policyholder currently aged 50 exact. The basic policy information, charging structure, and the basis used by the company to carry out profit testing are all set out in the question 2 base worksheet. The unit prices increase each year in line with the company's declared bonus interest rate. You should ignore non-unit reserves. Calculate the unit cash flows for each year for the policy per policy in force at the start of the year. So only the first part says unit cash flows, and there are no reserves maintained in the question. And this is the base sheet where we have been given the premium, the debt benefit, maturity benefit, surrender value, surrender benefit, surrender penalty, allocation rate, policy fee, bid offer spread. Dependent mortality is on the type. We have been directly given the dependent mortality, unit fund bonus rate, interest on non-unit cash flows, initial expenses, renewal expenses, claim expenses, risk discount rate. Okay. And we have here I have mortality and surrender, dependent mortality and dependent rate of mortality, dependent rate of surrender. So from using this, we can calculate the dependent rate of survival, APX, which is nothing but 1 minus mortality into 1 minus surrender, which is very simple. Okay. Now moving to the unit fund cash flows, which is very easy. The premiums are given as the question, which is 2,000 rupees. Cost of allocation in the first year is C16 into 1 minus C18, which is nothing but over here bid offer spread. If you see C16 is my allocation rate, and then bid offer spread 1 minus B2. So we have taken that, and from next year onwards it becomes 100%. Okay, so G16 and bid offer spread. Fund value at the end of the year before deduction of policy fee, it earns an interest rate. So this into 1 plus bonus rate of the unit fund bonus rate, which we get, which is 3%. Okay. Then policy fee is nothing but this fund into the fund management, your charge policy fee, which has been given, which is 1.2%. Okay. Into the, and this is deducted. So fund minus policy fee, we get this. And from next year onwards, this cost of allocation remains same. Fund at the end of the year, this fund value plus this fund value will get accumulated at the end, and a policy fee is charged over there and goes on. So last we get 33146.56. This is my unit fund projection. Calculate the expected non-unit cash flows for each year of the policy per policy in force at the start of the year. So now we have to do non-unit cash flow projection. So premium less cost of allocation, this was already given, so which is very easy from part whatever you have the premium already in this table. So this minus this table, you get the premium minus cost of allocation. Initial expenses and renewal expenses are again given in the base sheet. If you see, this is my initial expenses and these are my renewal expenses directly pulled out from there. Interest is nothing but premium minus expenses into the unit fund interest, non-unit fund interest rate. Policy fee can be directly pulled out from this table. We have a death cost. Death cost is here is what? Since the payment is nothing but surrender, death benefit is nothing but unit value. The unit fund minus unit fund is nothing but 0. Okay, so if I go here, my expected death cost, if you see, is C27 into 1 plus C24. So C27, if I see, which is nothing but only the claim expenses which will be charged if there is a claim, the C27 into 1 plus C24, because this is increasing. Each year there's an inflation, claim expenses are increasing in line with inflation. So if you see expenses here, which is C24, this is there. And sorry, this is, I have done, sorry, these are payable immediately on death. If I am not wrong, this is life and unitized profits contract, and if it's written over here, payments are paid immediately on death. Yeah. So in advance seizing immediately on death on surrender. So for immediately on death, I've just accumulated it to 1 year, 0.5 years, assuming that the payments are made at the mid of the year. So this is taken toward the end of the year. Death cost remains the same, only on the claim expenses it is being charged. Mortality is given directly to us. We just pulled the mortality. Expected death cost is nothing but death cost into AQXT. Surrender cost is again nothing but whatever is given. Surrender cost 400 is the claim expense minus the penalty which will be charged to the value. Okay, so C11 into Q1 G9. So G9 fund value, and fund at the and surrender will be charged on the fund value, which is surrender penalty. If I see, it is 15% percentage of the fund value. Okay. So this is my surrender cost, AQX, and expected surrender cost is nothing but these two values. Maturity benefit will only be charged, again claim expense, because again the unit fund value, and expected fund maturity benefit is nothing but 400 into the APX. Okay, for age this, for the given year. The present value is nothing but, profit vector is nothing but premium minus expenses plus interest plus policy fee minus expected death cost minus expected surrender cost and minus the expected maturity benefit. So this is what we get as the profit vector. Once we get the profit vector, we have been told calculate the present value of the profit on the so profit vector is given to us. Probability in force can be calculated 1, and this value is nothing but this value into the probabilities we have calculated in the base worksheet over here. Okay. And then profit signature is nothing but profit vector into probability. Discount rate is given to us in this last value, which is 6%. We have to calculate it on 6% risk discount rate, and to the power minus time, and EPV is nothing but profit signature. And this is my last answer. The present value of profit, 136.27. Moving forward to the third sum. So the third sum says the company has privately issued 3 fixed interest bonds with a term of 10 years, 15 years, and 25 years respectively. The bonds offer different coupons which are paid half yearly. The first coupon to be paid in 6 months' time. The coupon rates, redemption rates, and spot rates to use are set out in the worksheet. Question 3 base. Calculate the duration of each bond. Explained why a 10-year bond. Okay, so basically first they have to calculate the duration of each bond. So first let's see the base sheet. It gives us the spot rates here. Annual rates are given to us and coupons are paid half yearly. Bonds are all redeemed at par. Okay, and this is the spot rates from question 3 onwards. So first question 3 part 1 is very easy. We'll pull out all the spot rates which is there. Okay, nothing was given in the sheet. We're just pulling the spot rates. Then present value of bond 1. So bond 1 goes only for 10 years. Okay, so I have just put a formula. You can easily do it till 10 if you don't want to use ifs and don't want to make it complicated. I've made a complicated formula that if the time is less than 10, then the bond value, then the coupon rate into 100 by 2, since the half yearly coupon, into the discounting factor, which is basically 1 plus spot rate to the power time. Okay, and if it is equal to 10, then only the coupon value, which is this, plus the redemption value. Okay, I've just put it at once in the outset so that all the three, I just have to change the time and the coupon values, and the formulas will be same. Okay, so putting a if, I get this value for present value of bond 1, present value of bond 2, same formula, and present value of bond 3. But then bond 2 is for 15 years, bond 3 is for 25 years. Okay, so all these three I have got a present value. Then numerator of bond 1, numerator for duration. Duration is basically t time into the present value divided by the present value. Okay, so time into the present value summation we calculate. So t into the present value we have calculated, and we have done a sum. Numerator of bond 2 also same thing, 3 also same thing. The duration of bond 1 will be nothing but this divided by the present value of this. Similarly for bond 2 and similarly for bond 3. Explain why a 10-year bond with a coupon rate of 4% would have a lower duration than a 10-year bond with a coupon rate of 2%. So basically, if you calculate also, it gets proved that duration of 4% is less than 2% because 4% bond will provide higher interest rates. Okay, higher interest rates, and the term of redemption is in faster. Okay, invest with basically a long-term investment which gets affected with change in interest rates, where the one with the same redemption rate will not have much effect on the duration. Okay, so only it change the duration is lower because of the higher coupon rates, nothing else. Again, depends on different comments which people can give. 15 years after the issue, immediately after the coupon payment end due, the company defaults on the 25-year bond. The bond holders are unable to sell the holding as the bonds are privately issued. So there's no liquid secondary market. The company offers two options to the holders of the 25-year bond. The term of the bond remains at the original term of the 25 years. No further coupons will be paid, and bonds will be redeemed at 105%. Coupons will be immediately reduced to 1.25%. The term of the bond will be extended by 5 years. As a result, bondholders will expect a 0.5% risk premium over spot rates currently used, which I set out in the question work 3 base worksheet. Calculate the present value for the defaulted bond under both options at time 15. So first, If you see the risk premium is 0.5%, then we have been given the redemption of 105%, the coupon rate of 1.25%. Okay. For a coupon rate, this is for option 2 and this is for option 1. So spot rates with risk adjusted premium is what way is this spot rates? This is from now the question 3 part. If you see it's from question 3 part, we have to use this. So directly take it from there, and then if you see spot rate adjusted for risk premium, we just added the risk premium. Okay, extra interest rate which people take for extra risk. Present value of the option, it says nothing, but it says that the bond will remain at 25 years, but no coupons will be paid and bond will be redeemed at 105%. So only at the end, at the time of 10 years, bond will be redeemed at 105%. And present value of option 2 is coupons will be immediately reduced to 1.25% and the bond will be extended by 5 years. So now the term will go up to 5 years, means now 50 for a 15-year, 25-year, 15 years have elapsed. So it will go for now more 15 years. Okay, extension of 5 years. So again, if time is equal to 15, then there's coupon plus redemption. Otherwise, there's only coupon discounted with the spot rates. Okay, so you get the present value of option 1 to be this and option 2 to be this. Obviously, the present value of option 2 is better. Okay, and it is providing the coupons as well as redemption both. Okay, so again, this is this 2 mark is dependent on what you all want to comment. Calculate the duration of the bond at time 15 under the original conditions and under each of the options 1 and 2. So under original conditions, now we have only 10 years left. So for 10 years, we'll take out only those 10 years spot rate adjusted risk premium, and this is the original conditions. So this is the original spot rates. If you see under original conditions, these are my spot rates, and under original conditions, my duration will be again present value and the numerator of bonds under original conditions, which is nothing but this into the time and dividing. Present value under option 1 we have already calculated, option 2 we have already calculated. Just put the time into this, time into the present value, and then duration is nothing but sum divided by the present value for both the things. Okay. Many bondholders decide to select the other option than the one determined in part 3B. Suggest what other considerations they might have driven. So maybe in part 3B, we decided that people should go for option 2, but since the duration of option 1 is lesser, people might choose duration of option, or people might just stay at the original because they want earlier, they might be risk averse and do not want any other thing to happen in the future and might want the bonds to end early. Again, comments can be done based on personal judgment and so on. So this was very easy paper, very easy, direct paper. There was no such tricky parts in the papers this time for CM1 B. People might have taken time and might find it lengthy, but it wasn't if you know the concepts really well. Thank you.